All right, we're going to take a look at multiplying a polynomial by a monomial. So what we're doing is we're going to combine the distributive property with our laws of exponents that we've learned previously. Example 1, find negative 3x squared times the quantity 4x squared plus 6x minus 8. First thing we're going to do is we're going to distribute our monomial throughout our polynomial. I'm going to rewrite this as negative 3x squared times 4x squared plus negative 3x squared times 6x. So that's the second distribution, plus negative 3x squared times negative 8. I'm going to remind myself that minusing 8, I have to keep track of this negative, so I'm going to keep it as negative 8. Now I'm going to apply my exponent rules for each multiplication piece. So negative 3 times 4 is going to give me negative 12. X to the second times x to the second is x to the fourth. Plus negative 3 times 6 is negative 18, so I'm going to write that as minus 18. X to the second times x to the first. Remember, we have an exponent of 1 here. It's going to give me x to the third. And then in my final term, negative 3 times negative 8 is going to give me a positive 24. And then I just have the x squared to handle. Then I'm going to look, is there anything I can combine? I cannot. This is x to the fourth, x to the third, and x squared. I can't combine terms, so that would be my answer. I am going to rearrange them in a descending order, or want them in a descending order, so I'm going to check for that. Looking at the exponents, 4, 3, 2. So that's going to be my final answer. Example 2. Same thing here, except now I have I have to distribute twice. So I'm going to distribute the negative 2 through this set of parentheses. And then I'm going to, this is a very common part where students miss, I'm going to make this a plus and put my negative on the x to keep track of it. So I'm distributing a negative x through my parentheses. So I have negative 2 times 4x squared plus negative 2 times 5x. So there's my first distribution. Negative x times x squared plus negative x times 6x. So negative x times 6x. Now I'm going to go ahead, negative 2 times 4, negative 8x squared plus negative 2 times 5. It's going to be negative 10x plus negative x times x squared is going to give me negative x to the third. And then negative x times 6x is going to give me negative 6x squared. I'm not done. I have two terms I can combine. They have x squared on them. So negative 8 and negative 6 combines to make negative 14x squared. Then I have my minus 10x and my minus x to the third. If I were to rearrange these in a descending order for the exponents, it would be negative x to the third minus 14x squared minus 10x. Either one of these is okay. Either one of those is okay. Universally, we typically write exponents in a descending order. All right, let's look at another example. Negative 4 times c times x, so that monomial times my polynomial 10 plus 3x. I'm going to distribute. So I have negative 4cx times 10 plus negative 4cx times 3x. Negative 4 times 10 is negative 40. Still have my c, still have my x. Negative 4 times 3 is negative 12. Still have my c, and then the x times the x will give me the x squared. Then I can just write this a little nicer, cx minus 12cx squared. If we wrote this in a descending order with the exponents on the x, we would have negative 12cx squared minus 40cx. And our final example, example 4. I'm going to distribute. I'm not going to write the intermittent step. I'm going to just do my math. 2 times 3, 6. X squared times x, x to the third. Y squared times y, y to the third. Plus, I'm going to multiply by this term. 2 times 2 is 4. X squared, nothing to multiply it by, so it stays x squared. And then y squared times y is y to the third. Plus, final term, 2 times 5 is 10. X squared times x is x to the third. Y squared stays y squared. Nothing to combine here or simplify. X to the third and y to the third, I don't see that again. X to the second, y to the third. Although this looks the same, it's not. The exponents on the variables are different. So this would be our final answer. All right, we're going to look at one last piece. We're going to solve some equations involving this multiplication. Solving equations with polynomials. So our first step, so it says solve, which means we're going to find the value of n that works. First thing I got to do is distribute 4 times n and 4 times 2. So 4 times n gives me my 4n minus 4 times 2, 8. Bring down the plus 5n. Now on the right side, I'm going to distribute it as well. So 6 times 3 is 18. Minus 6 times n is 6n. And then we are going to add the 19. Now I'm going to go ahead and solve. So first thing, I'm going to combine what I can. So 4n and 5n, 9n, bring down the minus 8. 18 and 19, 37, minus 6n. Variables on both sides, so I'm going to add this 6n to get rid of it. Add 6n here, leaving me with 15n minus 8 is equal to 37. Add 8. 15n equals 45. Divide by 15. N equals 3. Example 2. 6 times x squared is 6x squared, plus 6 times 2x is 12x, is equal to 2 times 3x squared is 6x squared. 2 times 12 is positive 24, so plus 24. Nothing to combine here, nothing to combine here, so I begin to solve for x. I notice I have a 6x squared and a 6x squared. I'm going to subtract 6x squared on both sides. Going on the right, going on the left, leaving me with 12x equals 24. Final step, divide by 12, divide by 12. X is equal to 2. And that is solving equations that are involving our monomials times our polynomials or distribution.